Hello friends, my name is Aryan Prabhadesai and in this video I am going to tell you about SDLC, that means Software Development Life Cycle. So without wasting time, let's start the video. In this video we are going to see about what is SDLC, what are the stages of SDLC and what are the models of SDLC in detail. So first is what is SDLC. SDLC is a process followed for a software project within software organization. It is a framework defining tasks performed at each step in the software development process. It consists of a detailed plan describing how to develop, maintain, replace, and alter or enhance specific software. ISO IES is an international standard for software lifecycle processes. It aims to be the standard that defines all the tasks required for developing and maintaining software. SDLC consists of 6 types of stages. First is planning, second is defining, third is designing, fourth is building, fifth is testing, and sixth is deployment. And now we are going to see in detail as follows. Stage 1, planning and requirement analysis. Requirement analysis is the most important and fundamental stage in the software development lifecycle. It is performed by the senior members of the team with inputs from the customer, the sales department, market surveys, and domain experts in the industry. This information is then used to plan the basic project approach and to conduct product feasibility study in the economical, operational, and technical areas. Planning for the quality assurance requirements and identification of the risk associated with the project is also done in the planning stage. The outcome of the technical feasibility study is to define the various technical approaches that can be followed to implement the project successfully with minimum risk. Stage 2 is defining requirements. Once the requirement analysis is done, the next step is to clearly define and document the product requirements and get them approved from the customer or the market analyst. This is done through an SRS, that is Software Requirement Specification document, which consists of all the product requirements to be designed and developed during the project lifecycle. Stage 3 is designing the product architecture. SRS is the reference for the product architects to come out with the best architecture for the product to be developed. Based on the requirements specified in SRS, usually more than one design approach for the product architecture is proposed and documented in a DDS, that is Design Document Specification. This DDS is reviewed by all the important stakeholders and based on various parameters as risk assessment, product robustness, design modularity, budget and time constraints, the best design approach is selected for the product. A design approach clearly defines all the architectural modules with the product along with its communication and data flow representation with the external and third party modules. The internal design of all the modules of the proposed architecture should be clearly defined with the minutest of their details in DDS. Stage 4, that is building or developing the product. In this stage of SDLC, the actual development starts and the product is built. The programming code is generated as per DDS during this stage. If the design is performed in a detailed and organized manner, code generation can be accomplished without much hassle. Developers must follow the coding guidelines defined by their organization, and programming tools like compilers, interpreters, debuggers, etc. are used to generate the code. Different high-level programming languages such as C, C++, Pascal, Java, and PHP are used for coding. The programming language is chosen with respect to the type of software being developed. Stage 5 is testing the product. This stage is usually a subset of all the stages as in the modern SDLC models. The testing activities are mostly involved in all the stages of SDLC. However, this stage refers to the testing only stage of the product where product defects are reported, tracked, fixed, and retested until the product reaches the quality standards defined in the SRS. And now this last stage. Stage 6, deployment in the market and maintenance. Once the product is tested and ready to be deployed, it is released formally in the appropriate market. Sometimes product deployment happens in the stages as per the business strategy of that organization. The product may first be released in a limited segment and tested in the real business environment (UAT), that is user acceptance testing. Then based on the feedback, the product may be released as it is or with suggested enhancements in the targeting market segment. After the product is released in the market, its maintenance is done for the existing customer base. And now we are going to see SDLC models. There are various software development lifecycle models defined and designed which are followed during the software development process. These models are also referred as software development process models. Each process model follows a series of steps unique to its type to ensure success in the process of software development. Following are the most important and popular SDLC models followed in the industry: waterfall model, iterative model, spiral model, V model, and Big Bang model. So now we are going to learn about all of these models. First model is waterfall model. The waterfall model was the first process model to be introduced. It is also referred to as a linear sequential life cycle model. In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in this phase. First phase of the waterfall model is requirement gathering and analysis. All possible requirements of the system to be developed are captured in this phase and documented in a requirement specification document. Second phase is system design. This system design helps in specifying hardware and system requirements and helps in defining the overall system architecture. Next phase is implementation. With inputs from the system design, the system is first developed in small programs called units, which are integrated in the next phase. Each unit is developed and tested for its functionality, which is referred to as unit testing. Next phase is integration and testing. All the units developed in the implementation phase are integrated into a system after testing of each unit. Post integration, the entire system is tested for any faults and failures. Next phase is deployment of system. Once the functional and non-functional testing is done, the product is deployed in the customer environment or released into the market. And last phase is maintenance. There are some issues which come up in the client environment. To fix those issues, patches are released. Also to enhance the product, some better versions are released. Maintenance is done to deliver these changes in the customer environment. All these phases are cascaded to each other in which progress is seen as flowing steadily downwards. The next phase is started only after the defined set of goals are achieved for previous phase and it is signed off. So the name of waterfall model in this model phase do not overlap. In the iterative model, iterative process starts with a simple implementation of a small set of the software requirements and iteratively enhances the evolving versions until the complete system is implemented and ready to be deployed. At each iteration, design modifications are made and new functional capabilities are added. The basic idea behind this method is to develop a system through repeated cycles and in smaller portions at time. The following illustration is a representation of the iterative and incremental model. In this incremental model, the whole requirement is divided into various builds. During each iteration, the development module goes through the requirements, design, implementation, and testing phases. Each subsequent release of the module adds function to the previous release. The process continues till the complete system is ready as per the requirement. Iterative model application. Like other SDLC models, iterative and incremental development has some specific applications in the software industry. This model is the most often used in the following scenarios. First, requirements of the complete system are clearly defined and understood. Second, major requirements must be defined, however, some functionalities or requested enhancements may evolve with time. Third, there is a time to the market constraint. Fourth, a new technology is being used and is being learned by the development team while working on the project. Fifth, Resources with needed skill sets are not available and are planned to be used on contract basis for specific iterations. And last is there are some high risk features and goals which may change in the future. Now the next model is spiral model. The spiral model combines the idea of iterative development with the systematic control aspects of the waterfall model. This spiral model is a combination of iterative development process model and sequential linear development model, that is, the waterfall model with a high emphasis on risk analysis. It allows incremental releases of the product or incremental refinement through each iteration around the spiral. Design. The spiral model has 4 phases. A software project repeatedly passes through these phases in iterations called spirals. Identification. This phase starts with gathering the business requirements in the baseline spiral. In the subsequent spirals, as the product matures, identification of system requirements, subsystem requirements, and unit requirements are all done in this phase. This phase also includes understanding the system requirements by continuous communication between the customer and the system analyst. At the end of the spiral, the product is deployed in the identified market. Construct or build. The construct phase refers to production of the actual software product at every spiral. In the baseline spiral, when the product is just thought of and the design is being developed, a POC, that is proof of concept, is developed in this phase to get customer feedback. Evaluation and risk analysis. Risk analysis includes identifying, estimating, and monitoring the technical feasibility and management risk, such as schedule slippage and cost overrun. After testing the build, at the end of the first iteration, the customer evaluates the software and provides feedback. The following illustration is a representation of the spiral model, listing the activities in each phase. Based on the customer evaluation, the software development process enters the next iteration and subsequently follows the linear approach to implement the feedback suggested by the customer. The process of iterations along the spiral continues throughout the life of the software. So the next model is V model. The V model is an SDLC model where execution of processes happens in a sequential manner in a V shape. It is also known as a verification and validation model. The V model is an extension of the waterfall model and is based on the association of a testing phase for each corresponding development stage. This is a highly disciplined model and the next phase starts only after completion of the previous phase. V model design. Under the V model, the corresponding testing phase of the development phase is planned in parallel. So there are verification phases on one side of the V and validation phases on the other side. The coding phase joins the two sides of the V model. And now the last model is Big Bang model. The Big Bang model is an SDLC model where we do not follow any specific process. The development just starts with the required money and efforts as the input, and the output is the software developed, which may or may not be as per customer's requirement. This Big Bang model does not follow a process and there is a very little planning required. Even the customer is not sure about what exactly he wants and the requirements are implemented on the fly without much analysis. Usually this model is followed for small projects where the development teams are very small. Big Bang model design and application. The Big Bang model comprises of focusing all the possible resources in the software development and coding with very little or no planning. The requirements are understood and implemented as they come. Any changes required may or may not need to revamp the complete software. This model is ideal for small projects with 1 or 2 developers working together and is also useful for academic or practice projects. It is an ideal model for the product where requirements are not well understood and the final release date is not given. The advantage of the Big Bang model is that it is very simple and requires very little or no planning. Easy to manage and no formal procedures are required. However, the Big Bang model is a very high risk model and changes in the requirements or misunderstood requirements may even lead to complete reversal or scrapping of the project. It is ideal for repetitive or small projects with minimum risk. Thanks to GJC Computer Science Department and thank you all for watching this video.